right, geometry. Unfortunately, it seems like Google is having some issues today, so I'm recording this via a different method. So sorry, the quality might not be as crisp as it typically or as it usually is or sometimes is. But we're going to work with it. So today, we are going to talk about dilations. So dilations are actually a fourth type of transformation that we're going to jump into today. So if we think about it at the beginning of the year, we had three types of transformations. We had translation, we had reflection, and then we had rotation. So we're going to learn about this fourth transformation, dilation. And what dilation is dilation is growing or shrinking a shape by a specific scale factor. So when we dilate, we will all have a center that you would dilate about, similar to rotation, where we always rotate it about a center. With dilation, you will always dilate from a center. And then you will always dilate by a scale factor. Sorry if Google things keep popping up on my screen. It's because it's trying to sign into Google when it won't let me. All right, so it will always dilate by a scale factor. So for example, if we look at this example of a dilation, I have my original point here and my center. I'm going up to over 3 to get to that point. Well, if I look at my dilated point is having to go up 4 over 6. So if I look, each of these values are doubled. So my scale factor that I'm dilating by, which is typically represented by the letter K, K is always going to be that scale factor. That scale factor that I'm dilating by would be 2. And my center that I'm dilating about would be the coordinate point 1, 1. So in order to dilate, you need to know a scale factor and a center. Now, once again, dilation is having you grow or shrink. So the larger the scale factor, the larger the shape. If we look, this shape, if I look at my sides, I have a side length of 2, and I have a side length of 1. I know we don't have a grid, so it's not super easy to see. But if I look at my larger shape, and then whatever length this is, my larger length, I'm going from 7 to 11, so that's the size of 4. And then from 5 down to 3 is the size of 2. So if I look 2 to 4, 1 to 2, everything in my shape is being multiplied by that scale factor. I'm doubling everything. So scale factor, when we're dilating, we're always multiplying in size. We're multiplying by that scale factor. We're increasing or growing. So dilation is growing or shrinking by a multiple. Now, if we look at our shape, the reason we didn't learn dilation with our other transformations, we called our other transformations rigid motion transformations, where I started with a shape and my end shape always had the same exact shape. It always looked exactly the same. So if I started, or my translation, reflection, rotation, my image and my pre-image were always the same shape. They were congruent shapes. But with dilation, my shapes looked the same, but they are not the same size. So even though my angles might be the same and the shapes picture might still look the same, it's not quite the same shape because they're different sizes. So they're no longer congruent. So it's not a rigid motion transformation. That's why dilation is a little bit different, and we learn about it a little bit later in the year. But dilation's not too hard to calculate. So if we're given a problem like this, so I have this line here, DC, and my center of my dilation is the scale factor, or the origin, and my scale factor is 3. I want to dilate this line DC by that scale factor 3 from that center of the origin. And once again, dilation is growing or shrinking. When I have a scale factor bigger than 1, my line is going to grow. When I have a scale factor between 0 and 1, my scale factor is going to shrink, or my shape is going to shrink. So how I calculate dilation is I need to look what is the change in x and change in y from each point from my center to that point on my shape. So if I look from my center to C, I'm going -1, up 1. So I'm going to take that -1, and I'm going to multiply that by my scale factor of 3, which puts me at -3. And I'm going to take that rise of 1, I'm going to multiply that by my scale factor of 3, which is going to take me to +3. I'm sorry that this keeps coming up. So I now need to go from that scale factor, left 3, up 3. So left 3, up 3 is going to put me right here. So this is going to be C prime. Then I'm going to do the exact same thing with D. If I look, D is left 3, up 2. So that's -3 times 3. My scale factor gives me -9. And then 2 times 3 gives me 6. So from my center, once again, always starting from the center, I'm going left 9, up 6, and this is D prime. So this line right here is my new dilated line. If I look, the slope of this line was over 2, up 1. I should be 3 times that. So I'm going over 6, up 3 now. So my line is 3 times as long. Everything, or all the sides of my line, all the proportions of my line are multiplied by 3. So it's 3 times as big. It's also 3 times as far away from my center. Let's look at this next one. Dilate about the center of the origin with a scale factor of 2. So I'm going to look at point A, and I see I'm going over 1, 2, 3, 4, 5, 6, down 1. So if I think about -6, 1, if I multiply that by 2, that takes me, if I were to multiply each of those numbers by 2, that'd take me to -12. So I'm going to go for my center. Sorry, that's +6. I don't know why I said -6. So now I need to go over 12, down 2. I even forgot my negative on the 1. I'm sorry. And that is A prime. If I look for a B, B for my center is left 2, down 4. So that's -2, -4. I'm multiplying that by my scale factor of 2. So that, it gives me -2 times 4, or -2 times -2 is -4. -4 times 2 is -8. So for my origin, or for my center, I'm going -4, -8. And way down here is B prime. And then lastly, I have my point C. From my center, C is left 1, or right 1, up 2. So that's 1, 2. Multiplying that by 2, my scale factor, gives me a coordinate point at 1 times 2 is 2, 2 times 2 is 4, so 2, 4. So I'm going right 2, up 4. So this point up here would be C prime. And then this is my new shape. I'm going to use a line because it makes it a little bit better. So that's one spot. Second. And this is my triangle. If I look, my triangle, each side is twice as long. So my triangle is going to be bigger than twice as long. It's actually going to be 4 times as large, or something we'll look at in the future. But each side of my triangle is twice as long. If I were to count or calculate the length of each of these sides, it's going to be double because that scale factor was 2. So if a triangle ABC is dilated by a scale factor of 3, which statement is true for the image of triangle A prime, B prime, C prime? Is it 3 times the length of A prime, B prime going to be equal to the length of AB? Is BC going to, or B prime, C prime going to be the length of 3 times BC? Is the measure of angle A going to be 3 times the measure of angle A? Or is the measure of angle C prime going to be the measure of angle C? So we think about it. we have this triangle, A, B, C. And then we have 3 times the size of this triangle with A prime, B prime, C prime. So let's look at this first one. So this is saying the length of A prime, B prime, multiplied by 3. So we have to take this length multiplied by 3. That's going to be equal to this length. Is that true? No, because this is much, much larger. This is 3 times larger. So if I multiply this by 3, that's going to give me times 9. So that one is not true. What about BC? B prime, C prime is equal to 3 times my BC. So if I think B prime, C prime, is this equal to 3 times this size? Yes, because we took our original triangle multiplied by 3. So this is correct. I'm taking my shorter length, I'm multiplying it by 3 to get my longer length. Now, are my angles changing at all? No. If I look, my angles are still going to be exactly the same. If we look at our images from here, if we were to calculate these angles are all the same. My original angle and my dilated angle. They are all the same. The slope of those lines are still going to be the same. We're just growing the side lengths. So it's like when we were looking at triangle congruence, angle, angle, angle gave us the same looking triangle. They were just different sizes. So the angles are still the same, but the size of my side lengths are not. So my angles are still correct, but we're not actually multiplying them by any different sizes. All right, let's look at 2 more examples of dilations where the center is not the origin, and then we have some different scale factors. All right, so my center in this case is at 2, 1, and I'm multiplying by a scale factor of 1/2. So once again, all I need to do is I just need to look at where is my point compared to my center. So from my center, point A is left or right 1, 2, 3, 4, up 2. So it's 4, 2 from my center. I'm multiplying that coordinate by 1/2 to see what this gives me. I'm multiplying my x and my y by that. So 4 times 1/2 is 2. 1 times 1/2 is 1. So 2, 1, I need to put that from my center. So 2, 1 from my center puts A prime right there. I can do the same point with B. B from my center is 4, 4. So if I multiply 4, 4 by 1/2, that brings me to 2, 2, half of 4. So 2, 2 puts B prime right here. Now, from this, you can probably get a visual of what the rest of your shape is going to look like without having to calculate C or without having to calculate D. You can probably guess. If I think about this shape, each of my sides of my square here are a length of 2. If I cut each of those sides in half, that's going to give me a length of 1. So another length of 1 is going to put D prime right here. And another length of 1 is going to put C prime right here. So you might not need to do every single side length in order to calculate that. But this is my tiny square. And once again, I'm multiplying by a scale factor that's less than 1. Assuming you're multiplying by a scale factor less than 1 between 0 or between -1 and 1, your scale factor is going to, or your shape is going to shrink when it's a scale factor of less than 1. So we actually shrunk with our dilation. You're not always growing. So what happens if I multiply by a scale factor that's a negative? Let's see what happens here when I multiply by a scale factor that's a negative. So my center is -3, 2. Once again, I'm always counting from the center. I don't care about the origin if my center is no longer in the origin. So let's start with point D. If I look at D prime, from my center, I'm going left 2, up 1. So that's -2, 1. I need to multiply this by -2. Well, -2 times -2 is +4. 1 times -2 is -2. So from my center, I'm going +4. So 1, 2, 3, 4, up 2, 1, 2. No, sorry, down 2, 1, 2. So D prime is down here. If we look at point E, E started at, let's see, left 2, down 2. So negative 2 multiplied by negative 2 puts us at positive 4, positive 4. So for my center, I'm going positive 1, 2, 3, 4, and then up another 1, 2, 3, 4. So E prime is way up at the top. And then lastly, F for my center is left 1, 2, 3, 4, and then down 1, 2. So multiplying both those numbers by negative 2, that takes me to the coordinate point, positive 8, positive 4. So for my center, I need to go 1, 2, 3, 4, 5, 6, 7, 8, then up 1, 2, 3, 4. And this is F prime. So this is my new triangle. So if I look at my triangle, I actually flipped my whole shape. I started with D facing towards the top, and now I'm ending with D facing towards the bottom. So my triangle flipped. So anytime we have a negative, we're going to flip that shape. We're also ending up on the other side of our center. So if I look, typically I'm ending up I'm facing the same direction as my center. In this case, I'm completely flipped from my center. So it's a fun little trick whenever we were multiplying negative. One last trick I want to show you, and I'm actually going to go back to the very first example slide for this. Sometimes they ask you to figure out what is the scale factor and what is the center, or where is the center of your shape. So what is the scale factor and where is the center of your shape? So scale factor is typically pretty easy if you can figure out where the center is, and if you know like what your original, if you have like your image and your pre-image and you're trying to figure out where is the center and the scale factor, finding the scale factor is pretty easy because you can just look at those distances. See, I'm going up 2 over 3. So if I'm going up 4 over 6, I can see those are each a multiple of 2. So I know that I multiplied, or my scale factor is 2. Finding the center is a little bit tougher. So what we need to do in order to find the center is we are going to draw a line from each corresponding point in our image and our pre-image, and we're going to see where all 3 of these lines intersect. So if I draw a line from my image to my pre-image, and I have that keep going, I'm going to do that with each of my points. And if we look, each of these points are always going to intersect, or each of these lines are always going to intersect at our center. So if you're ever trying to calculate where the center of a shape is, draw 3 lines, or draw a line from each pre-image to the image, and keep extending those lines to see where each of these lines intersect, and they will always, always, always intersect at the center. It also gives you this cool like 3D visual where it looks like the shape is growing the whole time. So if we also want to multiply by a specific length along the line, we could create another dilated triangle along those lines using that as well. And that's all we're going to talk about with dilations today. You're going to have a bit of time to practice over this stuff. Let me know if you have any questions. I will upload it for you to watch it.